To find the prime factorization of a number, you need to create a factor tree. So we're going to start with the number 48. 48, the first thing I need to analyze is whether it's prime or composite. If it's a prime number, your process is over. That is the prime factorization. In this case, I know 48 is composite very quickly because it's an even number. So our goal is to find factor pairs of 48. I'm going to start with a simple one. 2 times 24 equals 48. The only rule with your factor tree is you can't use the number 1. If you use the number 1, you would never accomplish anything. So, once I've split it into two factor pairs, I look at both numbers to see if they are prime or composite. The number 2, I know that is prime, so it's a stop sign. We stop the process for 2. However, 24 is composite, so we continue the process, and we repeat. I'm going to split up 24, again with a factor pair that will multiply to equal 24 this time. I'm going to stick with my theme of 2, and 12. Again, I'm analyzing. 2 is prime, so it will stop there, and 12 is composite, so it will continue. And I'm now going to repeat the process again to find a factor pair for 12. I'm going to change things up a little bit, and I'm going to use 3 and 4 because I know 3 times 4 equals 12. And at this point, we are going to analyze. 3 is prime, 4 is composite, so the process continues for 4. There's only one factor pair I can use here for 4, and that is 2 times 2, because remember, I can't use 1 times 4. I split it, and I notice that both 2 and 2 are prime, so my process is over because the bottom of every branch in our factor tree is a prime number. Okay, that is our process for finding the prime factorization, but we are not done. I then take these numbers and I'm going to just move it off to the side for a second. My prime factorization is the process of multiplying every prime number. Now I'm not going to perform the multiplication because it's just going to take me back to 48. However, I am going to write out a multiplication string of my prime numbers. So I take my 2, my next 2, my 3, my 2, and my last 2. If you were to type this into the calculator, it would give us 48. If it doesn't, I made a multiplication error. So let's grab a calculator and check. 2 times 2 times 3 times 2 times 2 gives me 48, so I know my answer is correct. Now remember, I said there's a process, and there is your answer. This multiplication string is the answer. That is the prime factorization. The factor tree is the process to find that. Now, just to show you, I'm going to go through a little bit quicker this time. It doesn't matter what factor pairs you use and what order you do this in as long as you find correct factor pairs. I could start with 48 again. I'm going to go with 6 and 8. 6 and 8 are both composite, so the process will continue for both numbers. I find a factor pair for 6, 3, and 2, which I know are both prime, so they will stop. And 8, I'm going to use 4 and 2. 2 is prime, so it will stop. 4 is composite, so the process will continue. Gives me 2 and 2. They are both prime. And if you notice, it's going to give us the same factor string. I have 1, 2, 3, 4 2's. 1, 2, 3, 4. 1, 3, 1, 3. So it gives us the same answer. So the order doesn't matter. The factor pairs you choose do not matter. All that matters is that you are finding correct factor pairs, and remember, you are multiplying. You are not doing any addition in this process. So we have our process, which is our factor tree, and we have our answer, which is the multiplication string. Now I'm going to just steal that answer and show you how we can shorten it with exponents. Exponents, remember, is repeated multiplication. So I notice that I have the number 2 repeatedly multiplying 4 times. So I can write that as 2 to the 4th power, and then I bring my 3 down, which has no repeated multiplication. And that is the process of finding your prime factorization, and you can also write it with exponents to write it a little bit shorter.